we are going to explain you some things about sound, the propagation of sound, the speed of sound, and how sound is transmitted. Sounds in physics is any phenomenon that involves the propagation in the form of waves, generally through a fluid that is generating this vibratory movement of a body. Humanly audible sound consists of sound waves consisting of oscillations of any pressure, which are converted into mechanical waves in the human ear and perceived by the brain. The propagation of sound involves the transport of energy without the transport of matter in the form of mechanical waves that propagate through solid, liquid, or gaseous matter. Acoustic phonetics concentrates its interest especially on speech sounds, how they are generated, how they are perceived, and how they can be described graphically and/or quantitatively. The sound is transmitted in any medium, whether solid, liquid, or gaseous. When sound vibration occurs, the sound does not reach our ears immediately, but it has a way to reach it. The mediums are air, water, and solids. When we speak, the sound is transmitted through the air. When whales transmit their sound, it is transmitted through the water. And hitting the wood with your fingers, it is transmitted by solid medium.
There are three kinds of transmissions. Transmission area. A source of noise in a room sends air pressure waves that cause vibration to one side of a wall or element of the building structure in movement in such a way that the other side of the wall vibrates in an adjacent room. Highly sensitive areas of buildings, for example, recording studios, can be almost totally isolated from the rest of our structure by building studios as cash boxes supported by springs. The most important method of acoustic control is the addition of mass in the structure, such as a dividing wall, which usually reduces the transmission of airborne noise. Impact transmission. A source of noise in a room results from an impact of an object on a separation surface such as the floor causes it to transmit sound to an adjacent room. A typical example will be the sound of the steps in a play that is heard in a room below. Acoustic control measures usually include attempts to isolate the source of the impact or dampen it. For example, carpets will significantly reduce the sound.
Accompanying transmission. A more complex form of the noise transmission, where the vibrations resulting from a noise source are transmitted to other rooms of the building, usually by elements of the building structure.
Almost all the sounds we hear are transmitted through the air, but the sound is transmitted with more intensity and faster in the metal than in the air. The sound does not propagate in a vacuum. There must always be a medium. It is transmitted more quickly in liquids than in gases, and even faster in solids. The speed of sound in a specific material does not depend on the density of the material, but on its elasticity, which is the ability of the material to change shape in response to a speed and applied force, and recover its original shape once the force disappears.
In elastic materials, atoms are relatively close together and respond to the movements of others, so they can transmit energy with few losses. The propagate of sound is 50 times faster in steel than in air, and 4 times faster in water than in air.
This is the table of the speed of sound. When increasing the air temperature, also the speed of sound increases in almost 0.6 meters per second for each Celsius that the temperature increases. This is the formula to calculate the speed of sound according to the temperature.
The sound intensity is defined as acoustic power per unit area. The basic measurement is the sound intensity in the place of the listener. The basic units are watts over meter square and watts over centimeter square. The most common approach to measuring the intensity of sound is the use of the decibel scale. The decibels measure the ratio of a given intensity, the intensity of the hearing threshold. So that's the threshold takes the value 0 decibels. To evaluate the volume of the sound as a hallmark of an objective intensity measure, it must be weighed with the sensitivity of the ear.
In addition to gaining or hearing, are used for numerous technical and scientific applications. Mainly, it makes use of ultrasounds, sounds above the limit frequency of hearing of the human being. It's a technique that uses the propagation of sound underwater to navigate, communicate, and detect other fishing vessels or shoals, using the reflection of the wave in a similar way to what happens with echo. In the most common case, an emitter directs ultrasounds in seawater of frequency of order of 50,000 Hz.
The telephone is a telecommunication device designed to transmit acoustic signals remotely by means of electrical signals.
Intensity is defined as the acoustic power per unit area. The basic units are watts. Air, water, and solids. Transmission area, impact transmission, and accompanying transmission. It is the ability of a material to change shape in response to an applied force and recover its original shape once the force disappears. Sound cannot be transmitted in the back. Sonar and telephone. (340 meters over seconds) is the speed of the sound in the air.
Is a technique that uses the propagation of sound underwater to navigate, communicate, and detect other fishing vessels or shoals. They measure the ratio of a given intensity to the intensity of the hearing threshold. In conclusion, we can say that sound is the only form of communication in animals, while it is the case for humans communicate with spoken language beside body language. Without sounds, voice would have been difficult to be emitted out.
Music is the art which reflects solely on sound. Without sound, there is no music from music systems. Music communicates message. soothes the mind and also helps relieve stress. Sound waves are one of the few means available to measure the depth of the seas and also the deep holes in the earth.